So I'm going to start. So I'm going to talk about making Debian compiler agnostic. And basically, I'm going to present first the study of a rebuild of the whole archive using a new compiler called Clang or Clang. I will use both terms, basically the same thing. So in Debian currently, we have one compiler, which is called GCC, that pretty much everyone used at least once. So we are using it to build C, C++, Objective-C, Fortran, and a few other languages like Ada. It is supported on every Debian architecture and on every Debian kernel. In Debian, we have the Linux kernel, the K3BSD kernel, and the GNU kernel. So for now, it has been the reference in the compiler world for the last 20 years. Every Linux distribution is using it. It is used to build applications on huge clusters, but also for cell phones and so on. So it is really something that everybody is using now, and many people are contributing to it. And first, I'd like to say also that I'm a strong GCC user. I'm using GCC every day at my work. And I like to make a disclaimer that I won't be talking about the license of LLVM and Clang. So if you want to troll, no worries, but at the end, about this subject. So why do we want a new compiler in Debian? So the first reason that it is because we can. It is something fun with Debian. It is that every Debian developer can do it. Basically, I don't have anybody in Debian who will send me an email telling me that I have to stop working on this. So I can really do what I want in Debian. And for that, it is fun because it is a huge playground. We have so many packages in the archive, so many technologies, so many very skilled people that it is a great place to work on. And if I started this work, it's basically because I think it's fun. I think the future of Clang is bright, and many people are coming to use it more and more. So I'm doing that currently because I like it, and I found that very interesting on the technical point of view. But more seriously, I want to push Clang into Debian because the more you are using different compilers, the better it is. So you will find more error, more programming error. I will show you many examples where Clang beats GCC on error detection and warnings. So I'm experimenting that on my daily work. I'm working on a free software about numerical computation called Scilab. We are building the software every day with 4 compilers. So the one from Microsoft, the one from Intel, GCC, and Clang. And we realized that using these 4 compilers will strongly improve the quality of the software. So in Debian, I would like to push this idea more to improve the quality of the upstream packages. So that means that every Debian packages will be built with GCC and with Clang. So it really improves the quality of the source code and therefore the quality of the binary. It has some advantages that ARM is currently contributing a lot on the LLVM stack. Some people say that it is slower, some people say that it is faster on the ARM. Then the binary produced by GCC is slower than the one produced by Clang. I won't go into this discussion because I have no clue. I haven't tried, but some people say that it is going to be the binary currently are faster now using Clang than GCC. So next, what I like to do also is in Debian we have been able to decoupling the Linux kernel from the distribution itself. That means that you can use Debian with 2 other kernels, but you are not able to use Debian produced by another compiler than GCC. So I'd like to push more a way to remove the specificity of GCC from Debian and allow the usage of another compiler. So that means that you will be able to use Clang to compile the archive, but at some point you should be able also to do it with Intel compilers if you want, or Pascal compiler. So now I'm going to present the LLVM stack and Clang. It started as a research project by one PhD student. His name is Chris Lassner. He wanted to create a platform to do his research. He used to be a GCC developer, And originally, he wanted LLVM to be the base of the next generation of GCC. However, that didn't work because you have to manage the complexity of the software and the legacy, and people didn't want to change and do such major changes. It is more and more used in the research industry, in the research field. I've got some PhD friends or postdoc friends who are doing their research on LLVM. The main reason is that it is way easier to go into the C++ code of the LLVM stack than the GCC one, which is pretty hard to understand currently on some part. So Chris Latner has been contacted by Apple at the end of his PhD to continue his work on that. The idea of Apple is pretty clear, and they never lied about that they don't like the GPL license and they want a BSD compiler. So they have been producing GCC binary plus patches for a long time. They stopped that 1 or 2 years ago. And I think pretty much everybody is happy that they stopped because they made a lot of mistakes in the GCC packaging and so on. So they really invested on the compiler on the LLVM stack for a very long time. And now they have been able to build a very strong community on the software. So I did this statistic a couple months ago. So it's basically showed during the last 3,000 commits in LLVM and Clang who has been contributing. So basically I did a SVN log, I look at the author, I look if it was working for Apple, Google and whatever, and I produce this schema. So you can see that Apple is doing a bit less than half of the code currently. Google is doing a strong part. And you can see many other people like Intel, MIPS, Mozilla. There are many academics and individuals like myself who are contributing to this software. So what about Clang? So basically Clang is a parser and an analyzer for C, C++ and Objective-C. Currently there is no interest for Apple or Google to develop a Fortran compiler, but there are some people currently saying that they are working on that. For now, I have no clue if it is a proof of concept or if they really want to make a final version of a Fortran compiler, but it might happen someday. And it is currently the default compiler for Apple platforms and the FreeBSD project. You have the sources of the information at the bottom of the slide. So Clang has some advantages over GCC and some other compiler. Since the work started in the 2000 years, the base code is more cleaner. That means that the architecture is 2000 compliant and not 80s, are not from the 80s, so it is easier to get into the code to understand what things are doing and how it works. It has a very strong interest from many industrial hardware manufacturers. I haven't added as a list, but Sony and Samsung are also contributing to the source code. It is supposed to build faster than GCC. On the software I'm working on, it is true. I'm not sure it is true with every project, but most of the time it is. And one good advantage is that it accepts all GCC arguments. And if it is not the case, you can report a bug on the LLVM bug tracker, and they will implement the flag to make sure that it behaves the same way as GCC. So that means that if you are using GCC to compile for your project, instead of using CC equal GCC, you can replace CC equal Clang, and it should work out of the box if your source code is fine. But most of the time, it works without any issue on the argument. So some basic numbers. So using Clang instead of GCC, I gain 2 minutes on the Scilab build. It is not that much, but when you are doing that on 10 machines every day on full-time work, it is really worth it. So I'm going to show some advantages on the detection of the code. So if you don't know how to write C code, it's too bad for you because the next 10 minutes will be about C codes. So this one, it is one of the advantages of Clang, since they have a high representation, which is pretty clean. They have been able to do this kind of detection. So here, the compiler is able to detect that it will be always true. always false, sorry, on this one, because the I variable is unsigned. So that means that it will be always equal to 0 or positive. And if you look with GCC, I tried with the latest release into Debian, which is a 4.7, the latest table. GCC is not able to detect anything here. And Clang here is able to detect that and generate an error automatically. So, the side effect of Clang being more and more used and more able to fix and to find mistakes in the source code is that it brings some competition in the free and open source world. So here is an URL from the GCC website. Basically, GCC people realize that Clang is going to be more and more important, so they started to work on improving the diagnostic and the detection of error. So the many things have been improved in the error detection and in the error message in the latest releases of GCC. And the GCC people, the Clang people, when they noticed this page, decided to do the same here and explain why Clang is better than GCC. So it is bringing some competition in the free open source world, and many people are interested in both projects. So it is a very friendly competition here. So about the rebuild of the Debian using Clang. So I did this crappy method. Basically, since Clang is supposed to behave exactly the same way as GCC, you can basically remove the GCC compilers and replace it by Clang. So it is what we did on every virtual machine that we use to rebuild the archive. So we tested that on AMD 64. We haven't tried on the other architecture, and I'm sure that LLVM does not support every architecture that we've got in the Debian archive. But for now, it is working pretty well on Intel and ARM processors. And I haven't tested the performances. So that means that I haven't tested if the build is going faster or if the binary generated are faster, neither the quality of the binary. That means that maybe it is producing some bad binary codes, but I don't know that. I didn't launch a unitary testing suite. But I'm not afraid about that. I don't think there will be too many build issues in terms of binary creations. So all the results has been published during the last year on this website, so clang.debian.net. I'd like to thank also Luca and Amazon for giving us the opportunity to use the Amazon infrastructure. So basically, Amazon is offering a few $1,000 per year to do such kind of experiment, like rebuilding the whole Debian archive. So the first one that we did was Clang 3.0. So we had almost 9% of packaging failing. The second one was the 3.1 that we did last June, just before the Debian conference in Nicaragua. So we had 12% packages failing, and I'm going to explain why we had this increase. And I published the result about 2 hours ago about the 3.2, and we have exactly the same percentage. The number of packaging failing increased, but in the meantime, we increased the number of packages into the archive, which is normal. So I'm going to explain this kind of why we have this difference between the 3.0 and the 3.1. But first, I'd like to comment on this aspect. For people who are not very familiar with compilation of C code, these are two flags which are very oftenly used in building packages. So the first one is -WAll. That means that it enables all warning for C and C++ code. And the second one should not be used to software production, but only during development. So the -W error, that means that every warning found during the build process will be treated as an error. So basically, that means that if you have a warning, which is in this case the same example that I showed before, the build will fail instead of displaying a warning. So it has a side effect. That means that if the compiler is adding some new check into -WAll, it will fail your build. And Clang is adding way more checks than GCC when you are using -w all. So that makes way more errors. I will enter into the detail later on that subject. So with this argument, with -w error, and the default behavior of Clang, the compiler is able to detect when an argument that you used during the command line has not been used, which can be a nice feature when you really want to use a specific flag for your software. On my side, I don't care. I'm going to, usually when I'm calling GCC, I'm going to give him tons of include paths. And I don't care if they are not very interesting, but some people might be interested by such behaviors and such feature. Clang has introduced since the version 3.1 some security check. So obviously the error here is quite obvious, and Clang is able to detect this error and fail the build. We have 9 packages in the archive currently failing because of that. It is usually an important security issue. One of my favorites is this one. It is unsupported option. So we have packages in the Debian archive which, instead of using -03 or -02, they are using -09. We even have one package which is using -020, because maybe the developer thinks that if you use 20 times, if you use the 20, you will get 20 more optimization or something like that. We have 50 packages in the Debian archive which has this flag. This one also is very nice, and we should have all packages fixed here because it is a very important source of potential bugs. So that basically you have a function which is supposed to return something, and at some point in the source code we have a return which returns nothing. So that means that if you are using my function foo here, you will have garbage at the end. So you will have your program going nowhere or failing. And we have 133 occurrences of this bug into the rebuild of the archive. Well, I guess it is some very specific corner cases in the source code, but it is worth having a look too. So this one is quite similar. It is when you want to return a value of a function and the function is expecting void, that means nothing. So GCC will accept this source code, even if it triggers a warning, but Clang refuses this kind of declaration. I leave you decide what should be the behavior of GCC here, but I think the one of Clang is pretty clever. But it is crappy code, so you should not allow this kind of code in your C. So there is also another interesting bug. So here I added the 2 references. So basically I reported the first bug on LLVM saying this code doesn't work with Clang but works with GCC. They told me it's not a bug, it's a fixture. And I've been on the GCC bug tracker. I submitted this bug saying you accept this code while you should not, and they say it's not a bug, it's a feature. So basically, it is a different understanding of this keyword here. The friend class for Clang is behaving differently than the one in GCC when used with a static keyword. I leave you, if you want to have more details here, you have a look to, please have a look through the URL. So the Clang compiler, as I said previously, is giving way more warnings than GCC by default when you use -w all. So with this piece of code, GCC, even with using the -w all, won't display any warnings, while Clang here says that you should remove the parentheses on the if condition. So basically that improves the quality of the code. Clang also does not support some GCC specific extension. So here it is C++ code, and we are defining here a vector of int, and the size here is variable. And according to the specification, this should not compile. But GCC accepts this kind of declaration. It is an extension, and on purpose, C-Lang is not managing this kind of declaration. Here it is some code which are, it is a GCC bug. it is a piece of code which should not be accepted by GCC and which Clang refuses. So basically, it is because, if I remember correctly, it is because we are using the B function here while it is defined here. So we should define the profile of the function upper to be used. So here it is a bug in the C++ parser which allows this kind of features, but they agree it is a bug and they hope they will find it at some point. So we still have 34 occurrences of this kind of issues in the Debian archive. It is not a big deal since it works and the behavior, if you do code properly, won't change anything. So it's not a big issue, but G++ is failing to support the C++ standard. So my point of view here is that through the tools we build, we have been able to prove that Clang is now a viable alternative to build C and C++ code into the Debian archive. I'm not saying that we should replace GCC by CLang here, but I'm saying that it shows that it is able to compile most of the code. It supports most of the code which has been developed and used into the Debian infrastructure. And most of the problems which are remaining are upstream. That means that most of the bugs which are detected by Clang are upstream's bugs. So upstream should fix them at some point to be compiled with CLang. And most of the time it's very interesting to fix those bugs because it improves the quality of the software. So I'm going to present quickly what we've done during the Google Summer of Code of this year. So we had one update. So what I showed you before is basically a one-time rebuild of the whole archive during 6 or 7 hours at once. So what we wanted to do is to make it more permanent. So that means that every new package uploaded into the Debian archive will automatically be built using CLang. The goal at the end is to provide a way to switch easily from one compiler to the other to build your packages into the archive. So we had one student, Alexander, and the mentors were Paul and me. Unfortunately, the student, right after the last payment, stopped working on that, but it's part of the Google Summer of Code. Very common. So the first output for non-Debian people is not very interesting, but the infrastructure to rebuild packages is quite a pain to set up, and there were no documentation, so the student worked, lucky him, for the first few weeks on writing documentation on how to install this kind of PCs of software. So it took a while because it's not very well documented and there are very different versions of the software. So we set up a parallel infrastructure to build the Debian packages. So that means that it is not an official Debian services. It's something parallel that we are using on various computers. So we have the WannaBuild server, which will launch which will provide new build to be done by the Build services. And instead of using GCC, we are using CLang here. So we had to hack some Debian tools. So first we hacked dpkg to export some variables. So instead of hard coding the version of the compiler, we propose to use USR bin CC, USR bin C++, and USR bin OBGC. They are already set up in Debian. They are already handled by AutoTools and CMake. So we are proposing to use this one instead of hard coding the direct usage of GCC or G++. We are also doing some check. So Debian rules, for those who don't know what it is basically you define how the package is going to be built. So giving the argument, how to launch the compilation and so on. So we are checking that there is no hard-coded declaration to override the compiler. And finally, we are setting the USR bin aliases to the compiler itself. So that means here we are setting them to Clang, but we could set them to GCC and G++ if we want. In every Buildy instance, we are also adding a hook to install the Clang dependencies, and we are also removing the GCC, G++, and C++ binaries. We are removing them and replacing them by a script which will basically fail the build, saying you are using an hard-coded declaration of the compiler. You should not do that. You should use USR bin CC or use the variable CC instead of them. So the results are published on buildday-clang.debian.net. It's currently done because the machine is moving from one data center to the other. Hopefully it will be up tomorrow or the day after. We are publishing the results this way. So for example, it is the packages that I'm maintaining. So we can see that RPack here, the build went fine, which is normal because it is only Fortran code. So I'm using J-Fortran. But for example, for Dragon Egg, compiling with Clang worked. As you can see here, it built correctly. But for Code Saturn or for Clang instead, it failed. Because for example, for Clang, I am hard-coding GCC. I know that's bad, but I will fix that. But I am hard-coding the usage of GCC in this package. So what are the next steps? So we are proposing with Paul and a few other people to update the Debian policy to recommend not hard-coding the declaration to the compiler. So we would like to push that after the next release. Maybe for JC to say, okay, you are not supposed to hard-code the declaration of the compiler. You should leave to the Debian developer a way to make sure that he uses a new compiler instead of GCC here. So we already sent the proposal on the mailing list a few months ago. We haven't pushed that because of a lack of time, but we will get back on this the next few months. We are also planning to add a Lintian warning to detect that there is some hard-coded declaration in the build process. And we would like also to make all this information as much as possible available to the Debian developer, but also upstream developer. So the idea is that if you have a package which is into Debian, you will have automatically the feedback of your software being rebuilt by Clang instead of GCC. So you will have the logs and so on. And at some point, which we'll probably do in 1 or 2 years, is being able to create a parallel repository of a package built with Clang instead of GCC. For now, since the performance are pretty much the same, I don't see the point, but if and when Clang is faster than GCC, it will be worth it. And in the future, there are also some other parallel things that we would like to push. Clang has a plugin which is called Poly, which is a research project from INRIA and ENS, but part of the official LLVM stack, which makes polyhedral optimization, like Graphite in GCC. There is also a program called ASAN, Address Sanitizer, and Memory Sanitizer, which are basically static files included into your binary, which are going to keep track of address allocation error, memory leaks, and threading issue like deadlock and stuff like that. It is one of my favorite components of the LLVM stack. It's called ScanBuild. If you are doing C and C++ and you don't know that, I advise you to check out that tomorrow. It is really helping to find some common error in programmation, but on a very high level. That means that it can give you a very nice feedback like this one about memory leaks, difference of pointer and stuff like that. And it is really doing some high-level static analysis on your code. And it helps a lot to fix bugs and memory leaks. And at some point, if people are interested, this will allow to rebuild the archive with the Intel compiler. I won't do that, but I know that some people are interested in that, especially in the HPC world, since Intel's compiler are still way better than GCC and Clang in terms of performances. So another project that we worked on is with Andrej, who also quit at the end. It was a packaging of an alternative C++ runtime library. So in parallel of LLVM and Clang, the LLVM community is working on two C++ implementation. One is a standard library, and the other one is a low-level runtime support. So this sample C++ code, if we compile it by default by Clang, it will be linked again libstd C++. And if we are doing the same with this argument, it's still lib C++, it is going to be linked again to a new runtime C++ library. So the idea here, and I won't hide it, is Apple still hates GPL, so they want a C++ runtime library which is under a BSD license. So it's the purpose of this. It's always good to have various options. So we have that in Debian now. So if you want to give it a try, it is a new C++ runtime library. For now, I don't think there is a lot of performance improvement compared to the standard library, but at some point it might be interesting to have a look on this. It was more a proof of concept that we did here. So we upload that in July. There is still no official stable release from the LLVM community on this. And we are also working on the packaging of compiler RT. It's basically, I learned that not a long time ago, that there is also a C runtime library into Debian, and it is providing a replacement for that. The polydraw optimization will be available in Debian in the next few weeks. The package is ready. I'm just waiting for waiting for the FTP master to approve it. And LLDB, which is aiming to be a GDB replacement, but better. One of the advantages of LLDB is that you can evaluate complex C++ code into the debugger, while GDB is not able to do. So I finished to present my work on the rebuild, so don't hesitate if you have any question or if you want to say bad thing about Apple or other big players. Yeah. In fact, we are proposing the two solutions. We are proposing first to respect the CC equals something, and then if there is nothing provided, using USR bin CC, because they are not always provided this kind of variable. Did I answer to your question? With? No, I haven't. I don't think anybody did. As far as I know, nobody did. But I know that some people told me that they would like to do it. Okay, we can discuss after that because we could use the Amazon infrastructure to do this kind of rebuild. Okay. Any other questions? Okay, so thank you.